All right, today we're going to tackle a concept that's really changing the game for how teams manage their applications, GitOps. We're going to break down how it works and why it just might be the blueprint you need to prevent your next big production disaster.
Okay, so let's kick things off with a bit of a nightmare scenario, one that might hit a little too close to home. Picture this. Some well-meaning engineer runs a single command, kubectl apply. Think of it like just shouting an order directly at your system, and they do it on your live production environment. Suddenly, everything crashes. The team scrambles, but nobody has a clue what actually changed because there's absolutely no record.
And believe it or not, this isn't just a hypothetical. For one team, this exact thing happened. And that single untracked command ended up costing them an estimated $200,000 in lost revenue. That is a huge price to pay for a mistake that, honestly, could have been avoided.
So you've got this team, right? They're stuck in a war room for 4 straight hours, frantically comparing configuration files, just guessing at what might have gone wrong. There's no audit trail, no easy way to roll back the change. And all that chaos, all that stress, it all boiled down to one single fundamental problem. They had no single source of truth for what the system was supposed to look like.
So yeah, the root of all that chaos was pretty simple. There was no plan. And to prevent that from happening again, we need to stop giving our systems these improvised verbal orders and instead start working from a master blueprint, one that not just the people, but the machines have to follow.
And you know, this analogy of a blueprint is actually perfect. Think about it. The old way, that's like a foreman on a construction site just yelling out random orders. Hey, put a wall there. Now wait, move it. It's total chaos. Things get missed, and nobody really knows the full plan. But the new way, the GitOps way, that's like having this incredibly detailed master blueprint. Every single change is recorded on it, and the only job is to make sure the building perfectly matches that plan.
And this is what that difference looks like in the real world. You go from that awful feeling of, I think I deployed the right version, to the absolute certainty of just looking at Git and seeing the exact state. If something breaks, you don't have a panic-filled investigation. You just type git revert, and poof, you're back to a working state. It's an instant rollback. Every change is tracked. You always know who deployed what and when. It's a complete shift from chaos to control.
Okay, so let's really get into the weeds here. How does this master blueprint idea actually work? Well, it all rests on 4 core principles. These are the pillars that make the whole thing stand up.
First up, everything is declarative. Now, what does that even mean? It means you stop telling the system how to do something step by step. Instead, you just declare what you want the end result to be. You write a file that says, I want 3 web servers and they need to be running this exact version of the software. The system itself figures out how to make that a reality. Second, and this is, the Git and GitOps, that blueprint is version controlled. What that means is every single change, no matter how tiny, gets saved as a commit. It's like a perfect unchangeable diary for your entire system. You can see exactly who changed what and when they did it. No more mysteries.
All right, principle number 3. The delivery is totally automated. So once a change gets the green light in Git, you're done. Your job is over. The system just takes it from there. Software agents automatically grab that new blueprint and apply it to your live environment. This completely gets rid of that risky manual step that caused our disaster story in the first place.
And finally, the 4th pillar, this whole thing is managed by software agents. I love this analogy. Think of a tool like ArgoCD as this super vigilant robot foreman that lives inside your Kubernetes cluster. Its only job, 24/7, is to compare the real world, the live cluster, against the master blueprint in Git. If it spots any difference at all, we call that drift, it immediately fixes it to match the blueprint, no questions asked.
Okay, so we've got these 4 principles, right? Declarative, version-controlled, automated, and agent-driven. How do they all fit together in a real-world workflow? Let's walk through it, from a developer's keyboard all the way to the live cluster. Okay, check this out. It all starts with the developer, just doing their job, committing a change to Git. From there, a continuous integration, or CI pipeline kicks in to build and test the code. If everything looks good, the pipeline automatically updates the configuration files, the blueprint, in Git. The moment that happens, the GitOps agent, ArgoCD, sees the change. It pulls down that new blueprint and syncs the cluster to match. And this whole thing just becomes this beautiful, self-correcting loop. Git is always the source of truth.
So, that's the how. It's a pretty slick system, but the big question is, why? Why go through all the trouble to set this up?
What's the actual payoff here? Well, the first thing you're going to notice, and it's a big one, is speed. Just raw speed. By automating this whole deployment pipeline, teams are seeing huge reductions in the time it takes to get code from a developer's laptop into production. I mean, we are talking a 60 to 80% improvement. That's not just a little faster, that's a total game changer for how a business operates.
But look, it's not just about speed, not even close. Your systems become rock-solid reliable because the live state is constantly being forced to match the blueprint. You get a perfect audit trail of every single change. And get this, in a true disaster, you can recreate your entire system from scratch in minutes just by pointing a new cluster at your Git repo. It even makes developers' lives easier because now they can deploy their own stuff just by doing what they already do all day, pushing code to Git.
Now, this all sounds pretty amazing, right? This level of automation, of control, it's powerful stuff. But, and there's always a but, it's not without its risks. There are a few common pitfalls you really have to watch out for.
And one of the biggest gotchas is something called the auto prune trap. So you can tell your GitOps agent, hey, anything you see running in the cluster that's not in my blueprint, just delete it. It sounds efficient, right? But imagine someone accidentally deletes a critical config file from Git. Well, that little robot foreman is going to do exactly what you told it to, and poof, there goes your production database. You have to be incredibly careful with that kind of power.
And really, what this all comes down to is a pretty fundamental question about control. The whole point of GitOps is that your blueprint, the code in Git, is the boss. It dictates reality. But without real discipline, it's so easy for little manual fixes to sneak in, causing reality to drift away from the plan. So the question I want to leave you with is this. In your system, which one is really in control? Because as we saw at the very beginning, when reality starts controlling your blueprint, things can get very, very expensive.